Thanks for coming to my talk. Deploy green, verify, promote blue-green releases with API Gateway and Lambda. The QR code that is up on the screen is a link to my GitHub repository that has all of the code that I'm going to be talking about today. If you find this talk to be kind of light on the details and heavy on the AI-generated imagery, please see the repo. I'll be continuing to work on it because it's kind of a work in progress. But everything I have the Terraform, I have GitHub workflows, I have some kind of naive lambdas just to be behind the API gateway, and it's okay that the lambdas are naive because the lambdas aren't important in this demo. It's the other stuff. So my name is Ben Osborne. I'm a software architect with a company called Milliman IntelliScript. So we are a software as a service company in the insurtech industry. We're located in the Milwaukee area. And we're Amazon partners. And we usually have several openings for software engineers, data engineers, and you'd be working heavily with AWS, and they're fully remote openings. So if that sounds good to you, just check out the current openings and feel free to ask me any questions about the company. We are going to start with a metaphor. So this warrior he's your application in production, or I just say it. And maybe that's how we think of our application in production. But if you look at the image, if this is how your application is performing, that's pretty good, right? It's facing some load. It's performing. It's stable. It's beat up a bit, but it's doing its job. But like any application that, I've got some animated slides here. If you're watching the video on YouTube, that's a PDF version that you're not going to see the animations, but you can use your imagination. And so if our application is an API gateway with Lambda integrations, it looks something like this. We've got multiple consumers, we've got multiple APIs, and they're backed by Lambda integration functions. Maybe you've got one function for your entire API, and maybe you've got multiple. It doesn't really matter. But like any application that's kind of living in production, we're learning from it. We're able to monitor the performance. And after a while, we're going to come up with things we want to change about it. We're going to want to upgrade it. Maybe we need to upgrade the platform version. If you're a .NET shop like us, you're probably working on doing some .NET 8 to .NET 10 upgrades right around now. Maybe there's just new business functionality, but we're going to want to upgrade our application periodically. And so when we do that, we get our new version of it. That's this warrior on the right. And on paper, it looks really good, right? It's going to have everything the old version has. It's got a sword, and it's got a shield, and it's got some improvements as well. So we're hoping that it does great. It's been tested in lower environments. It's probably going to do great. And so we're going to do most teams that if you're starting working with the API Gateway, or maybe this is just how your teams have already done things. You do what's called an in-place upgrade. And so this replaces the current production serving version of the Lambda function with the new version. And even though this is a data plane operation in AWS, it's pretty safe. API Gateway and Lambda they're very resilient. It's not going to try to start using the new version of the function until it's fully transferred over there. And if something fails and the new version of the function fails to deploy, it's not going to even try to use it. It's going to keep using the old version. So this is pretty resilient. It doesn't drop in-flight requests. So a lot of teams will say this is good. It's simple, so we're just going to stick with this. But what happens when we kind of learn something about this new version of the function that did not come up in lower environments for whatever reason? Suddenly we've got a bug. And our API is broken. And so here's our warrior. Even though he was fine in lower environments, we did not test him in production until now. And it turns out his sword has a problem. His shield has a problem. He's not doing well. So if you've run into this situation, we know that we usually do the rollback, right? So restore the last known version. And hopefully that's automated, or hopefully that's relatively easy to do. Maybe you're in a maintenance window, so it's not a big deal if you took an outage. But you did take an outage. And here we have like the city is burning in the background. We have some kind of fallen warriors. And so hopefully when your API takes an outage, the consequences aren't so severe. But that's kind of like the bad scenario. Usually the new version does great, right? Like in here we have the new version. It is like, it's doing awesome. It's got upgrades. It's performing better than the current version, and that's what we wanted. But we didn't really know if we were going to get this, if this was going to happen, or if this was going to happen. And so usually we're sitting on an upgrade to our application, but we don't want to deploy it because we're not confident in it yet. We're going to wait until a off-hours release window. We may have to have a developer on call for that release because it's not inside of business hours, and it may be days, it may be a week, it may be multiple weeks. So in the meantime, we're not benefiting from the improvements of that version of the application. So I am going to demonstrate an approach that lets us deploy when we want to with high confidence. And there is nothing cutting edge or novel about this, but from what I've heard and from what I've seen, a lot of teams are sticking with kind of the in-place upgrades because that does work most of the time, and it's good enough and it's simple. But so I'm going to show you still a simple approach, but that will give us the benefits that I've been mentioning. And so I'm almost done with the AI-generated artwork, so just bear with me if it bothers you. Okay, so we're going to go back to our original warrior. So that we're back with this warrior. He's the current app version of the application that's serving live traffic. We're going to call this the blue warrior. And then our incoming version, our candidate version, we're going to call that the green version. If you have trouble kind of keeping track of the blue-green terminology, if you just think of synonyms for green, that often means kind of new, untested. These are synonyms from Merriam-Webster. And so Amazon has several services that do native blue-green deployment. And they use these terms consistently with how I'm using them. But what we want to do is deploy the green version to production, the same environment as the blue version, run whatever tests that we want, whatever tests that we need to run to satisfy that the green version is going to work, but not serving live traffic yet. The blue version continues to serve live traffic. Only when we're satisfied that the green version passes all tests in production, that's when we promote the green version to blue, and we retire the old blue version. That becomes the previous version. So I'm going to talk about how we do this with API Gateway and Lambda. So the first thing we need is multiple deployment stages. So an API Gateway stage is just a named environment for your API Gateway. In order for your API Gateway to be reachable, you need at least one stage. So most, you have one stage minimum. That's usually called something like the live stage. You're gonna need a second stage. We'll call that the test stage. And what we can do with this test stage is that we can deploy our API there first, run some tests against it, and if those tests fail, then we know that our updates are bad. We're not going to promote them to live. Live traffic was never affected, and so that's good. So how do multiple stages work with a Lambda integrated when our APIs are backed by a Lambda function? So here's our in-place upgrade again. And so we're running tests against the new version of the Lambda, and it looks like we've broken production on both stages. So the reason that happened is because we have multiple stages, but we still only have one version of our Lambda. And so that version of our Lambda is called latest or $latest. So by default, if you're using Lambda and you haven't opted into version publishing, latest is the only version that there is. There's only one version. Latest is a name that refers to the latest mutable version of your function. And so we're going to need more versions of our Lambda function. So for that, we are going to opt into version publishing. So with version publishing, every time you publish a new version of our function, it keeps the old versions and just creates a new version. And that latest name is always going to be the latest version that we've deployed. So if we have different versions now, that's great, but our API gateway is still using that latest version. It doesn't know to use a particular versions of our functions, and so we've got some more work to do. So how do we get our Lambda? How do we get our API gateway to invoke a particular version of our Lambda function? So we need to change our invoke ARN. So the invoke ARN of a Lambda function, if you use any kind of IAC tool. I'm a Terraform guy, so I don't know CloudFormation very well. So, but in Terraform, if you're just dealing with the latest version of a Lambda function and you need that Lambda's invoke ARN, you've probably never seen this super long verbose qualifier with a date in the middle of it, because that's a property of the Lambda function. You don't really have to worry about kind of constructing that. Well, if you need to use if you need to qualify that Lambda, then you do have to kind of construct that extremely verbose URI, and because after the Lambda function name, you need to add a qualifier. In this case, we've got a :4 after the name, and so we're going to have our API gateway invoke version 4, and so that's a win. So now we're controlling which version that our API gateway invokes. We're not automatically just invoking latest, so we've got some safety there. But that's still not enough, because we want our test stage to be able to invoke a later version of our Lambda, right? Like in this case, version 5 is the incoming version. That's the version that we want to invoke on test. And in order to get our Lambda functions to invoke, our API gateway stages to invoke different versions of our Lambda, that's when we need to introduce stage variables. So stage variables are key value pairs that are scoped to API gateway stages, and they can be different for each stage. And so we're going to add a stage variable called function version. And on our test stage, we're going to make that a 4, and then on live, we'll make that version 5. So again, with our invoke URI, you need to construct it, and to use a stage variable, you have to use this double $ syntax, which makes it even somehow uglier. So now we have our API gateway stages invoking different versions. So this is great, right? So test is invoking version 5. Live continues to invoke version 4. If 5 is broken, we haven't affected live traffic, and so that's good. This is probably viable, but you don't want to stop here, because those version numbers don't carry any meaning, and you're not going to be able to keep track of like which version is serving live traffic and which is like the candidate version. And so that's when we want to go right into our next concept of aliases. So we're going to create a couple different aliases here. We're going to create a blue alias. And so just like our metaphor earlier, blue is going to refer to the current production serving version of our Lambda function. Now, the key is with the blue alias is that the blue alias can be initially provisioned with infrastructure as code, but it can't be updated to infrastructure as code. So in Terraform, this is accomplished through a life cycle rule. I don't know how it's accomplished with CloudFormation, but I'm sure there's a way. But we don't want Terraform to update that, because that's going to be updated only when we're satisfied that the new version of the Lambda passes tests. So the green, on the other hand, that is going to be updated by our Terraform, and so that's usually going to be whatever latest is. All right, so we're going to get rid of that function version, a stage variable, and then we're going to add a stage variable called alias, and then we'll use the value of blue for the blue stage and green for the green stage. And then we're just changing that invoke URI to use that alias variable. And then we're also going to change our stage variable, the names of our stages. We're going to have a blue stage and a green stage, and they'll have that stage variable that's the same as their stage name. That kind of makes things easy to keep track of. So with that in place, so you can see here in this animation, blue and green and latest are all pointing to version 4. What happens when we deploy version 5? So we will deploy that with our CI/CD pipeline, Terraform. So now green and latest point to version 5. And we can run tests against green. We don't have to even think about versions. It's just all easily discoverable just through naming conventions. If tests pass with that version, then we run a control plane operation, which is a Lambda update alias. There's more arguments. It's not just update alias, and you just specify details. But the command is update alias, and that basically changes the version that blue was pointing to the version that green is currently pointing to. So that's promoting green to blue. And like I said, that's a control plane operation. It's very safe. No in-flight requests will be dropped. One other thing that I find is helpful is to have introduce an additional alias called previous. And so with previous, when we do that promotion from green to blue, we're also going to take the version that blue was pointing to and then point previous to that version. And that's so we can do a rollback if we need. Have a GitHub workflow or whatever your CI/CD provider is, have a workflow that you can do that rollback. You're probably never going to have to do a rollback, but I've seen enough change management forms where the question is always, what's your rollback plan? So we want to be able to check that box. We want to be able to have a plan. So it doesn't really hurt to have another alias. So I highly recommend having that previous alias. And then finally, we want to clean up. I thought I showed that one already. I guess I didn't. Okay. We want to clean up any old versions of our functions. We don't want to accumulate them indefinitely. They do count towards Lambda storage limits, and they count towards concurrency quotas. And so we want to be careful to prune any lambdas that we don't need anymore. So I recommend one more automated step of your deployment pipeline to just delete any versions that aren't associated with an alias. So the next question is, okay, what can go wrong? So of course, there's things that can go wrong. I will say, of the things that I've seen gone wrong, they all were caught or should have been caught well before production. Not that there aren't other things that can go wrong, but these are the things that I've seen. Okay, so the first thing is permissions. In order for a Lambda function to be invoked by API gateway, the Lambda has to have a resource policy allowing that. That resource policy is not going to get automatically inherited by function versions and aliases, and so you're going to want to add that policy to your blue and green aliases. Keep the permission on the latest version though, and because if you're going from API gateway that was just using in-place upgrades to blue-green, if you drop that permission on latest, you're gonna cause a temporary downtime as your API gateway can no longer invoke that unqualified Lambda, and I do know that from experience. The second thing that can go wrong, custom Lambda authorizers don't support stage variables. I really wish AWS would just change it so that you can use stage variables with custom authorizers, but as of now you can't, and I don't see any indication that they're working on that. So if you've got a custom Lambda authorizer, have a separate deploy pipeline for that, and you can't use this blue-green approach with that. There's other ways you can do a blue-green deployment with your custom authorizer. My organization we're not doing that yet. We don't have to update our authorizer that frequently, so it's not that much of a pain point, but I am thinking of ways to accomplish that. It's probably going to involve like a direct Lambda invocation in integration tests or something like that. But I'll update my sample repo once I kind of come up with an implementation of that I like. The last thing that can go wrong, IAC is not blue-green aware, so I mentioned in order to keep Terraform from trying to update your blue Lambda version, which it's going to want to do, you need something like a lifecycle rule to ignore changes to the Lambda version. And yeah, this can be different in CloudFormation, but just of course it's always important to review Terraform plans. If you do something like a big change, especially, just make sure that blue version of the Lambda is not getting recreated, because if that happens, then your blue-green strategy is pretty much out the window, at least for that particular deployment. Yeah, and so I think that's all I had in my demo. So that QR code, it's up on the screen again. I do have these cards. If you've got like dev teams that you want to like share this with, you're welcome to take one or more of these. 3D printed cards is excessive, but I do like to 3D print things.